below 60 ever, no matter the circumstances. Right now, we're playing on the PS4 version of.
All right, guys. So quiz 9. The only feedback I have is some of you didn't know how to differentiate. I don't know whether you realized I actually did a video on differentiation. Did you guys watch this video? There was a video on product rules for differentiation, which is this one here. And there's also handwritten. I mean, if you can't watch the video, then at least you could see the notes. I mean, this is the product rule for product of 2 functions, and this is the product rule for product of 3 functions, and this is the product rule for the product of n functions. So all you had to do was to use these rules, and some of you made mistakes when you did the differentiation. You couldn't get it right. But I thought you looked at this video earlier, so I don't know what the problem was. So maybe you guys didn't see this video. Anyway, so I hope you got what I mean. I hope you guys looked at the solution and learned where your mistake was. Right, but I think most people got the correct answer. So I think it's well done for those of you who got the correct answer. All right, today is the last chapter of the semester of this course. So this chapter is going to be the chapter on bivariate extreme value theory. I hope you guys had a chance to look at these videos. I mean, I always ask you guys to look through the videos before you come to the lesson. So I hope you looked at some of these videos. Now, before I start, next week is week 11. Week 11 will be a revision class. So I'll prepare you for the exam, which is on the 26th of January. So any questions, you can bring it next week. I mean, of course, that doesn't mean you can't ask me now. You can contact me 24/7 anytime. So I'm happy to answer any questions anytime. All right, so let me start on this chapter, which is the final chapter of this course. All right, so let me change the camera. The camera is here, right? Right, here we are. Okay, now you may recall that one of the first chapters we looked at in this course was the univariate extreme values, and when I talked about it, I showed you the extremal types theorem, which says that the possible limits can be one of 3 distributions: the Gumbel, or the Frechet, or the Weibull. Now, as the final chapter of this course, I'm going to look at what happens if you look at bivariate extremes, not just univariate, but extreme values of 2 variables at a time. And these are important for many reasons. For example, if you look at tornadoes, right, which are common in the United States, I mean, these are caused by extreme values of humidity and wind speed. So you have extreme values of humidity, 1 variable, and wind speed, a 2nd variable. So you have extreme values of 2 variables, right? Another example is forest fires. And these are caused by extreme values of temperature and wind speed. So again, you have extreme values of 2 variables. Next example is this one, droughts. Droughts are caused by extremely low values of rainfall and extremely high values of temperature. So again, you are dealing with 2 extremes of 2 variables, right? The next thing is hurricanes, and these are caused by extremely high values of sea temperature, extremely high rainfall and extremely high wind speed. So here you are dealing with extreme values of 3 variables, right? And next is the floods. I mean, floods are common in this part of the world. These are caused by extreme values of rainfall, high rainfall and high wind speed. So here you're dealing with extreme values of 2 variables, right? The next example is El Nino. I mean, you might have heard about this. These are caused by extremely high sea temperatures and extremely high air pressure. So here you're dealing with extreme values of two variables, right? So these are just some of the examples where the extreme values of more than one variable are of interest. Okay, so suppose you have 2 variables, X and Y, and suppose these are data on X and these are data on Y. Now the first question is, how do you define an bivariate extreme value? There are many ways of doing it. The most common way is this is the most common definition. So you take the maximum of the data on X and you take the maximum of the data on Y, and you produce this vector. So this is known as the bivariate extreme value, right? Now the question is how we want to look at you may remember in the univariate case, we did not look at the distribution of the sample maximum directly, but instead we looked at the distribution of a scaled version of the MN1, which is the first. Remember, MN1 is the notation for this, and MN2 is the notation for this, right? So what I'm going to look at is the joint distribution of the scaled version of MN1 and the scaled version of MN2, right? So Bn, An, Dn, Cn are constants. So this is the joint distribution. And if you do the mathematics, I'm not going to go through this now. I mean, you can go through the mathematics in your own time. And if you don't follow, please contact me. Please contact me 24/7. Okay. Now, so if you look, if you do the mathematics for this joint probability, this is what you will get as the final expression, right? So here F denotes the joint CDF of the original data, right? This comma this power n. Now I call this star for a reason. The question is, what is the limit of star as n approaches infinity? N is the number of data points, right? Now, in the univariate case, you will know the answer for this question. In the univariate case, the answer to this question is one of 3 possible limits, the Gumbel, Fresher, or Weibull. But unfortunately, that's not true in the bivariate or multivariate cases. In the bivariate case, the possible limits for star are uncountably infinite. I assume you know what this means. That means there are uncountably infinite possible values for star. I mean, possible limits for star, which I call capital G, X, Y. Now, if the limit exists, then G of X, Y is known as the bivariate extreme value distribution, right? And there is, in spite of this bad news, there is a way to determine what G is if the limit exists. And the procedure is as follows, right? Okay, before I go to the procedure, let me summarize what I have just said. So you have data x1, y1 to xn, yn, and this is the definition of a bivariate extreme value. We are looking at the joint CDF of this, which is this, and if the limit exists, G, right, G is known as the bivariate extreme value distribution, or short BEVD, right? Now there is a procedure to find G of X, Y, which I'm going to describe not right now, right? The procedure is 4 steps. The first step of the procedure is to find the marginal CD of fx and fy of capital F. Remember, capital F is the CDF of the data, right? The second step is to find the max domain of attraction of fx and fy. Because fx is a univariate CDF, and so is fy, they must belong to one of three possible domains: the Gumbel domain, the Fréchet domain, or the viable domain. Step 3, if fx and fy belong to the Gumbel domain, choose A and B and C and D and as follows. If they belong to the Fréchet domain, choose A and B and C and D and as follows, right? And finally, if they belong to the viable domain, choose A and B and C and D and as follows. And step 4 is to find the limit of this power n as n goes to infinity. So this is the 4-step procedure for finding the bivariate extreme value limit, if it exists, right? It may not exist at all, but if it exists, you must follow this procedure, right? Right. Then this is an example I did in the video, so I'm not going to go through this example. I will do an example later on today, at least one, but this is an example I did in the video. I hope you watched that video, right? So it's a lot of math. I mean, it's basic maths. I mean, but it's not a difficult maths. All right. The other thing I want to talk about is representations for possible forms for G. Remember, G, the possible forms for G can be uncountably infinite. However, the possible forms can be unified into certain representations. And that's what I'm going to talk about last. If fx and fy belong to the Gumbel domain, then the possible forms for G can be written in this form, right? Where these two functions are non-negative functions and they integrate to 1, from 0 to 1, right? The next one is this. This is number 2, representation number 2. If fx and fy belong to, once again, the Gumbel domain, then the possible forms for G can be represented in this form, where K is a function that satisfies each of these 5 conditions, that the limit t goes to infinity must be 1, limit as t goes to minus infinity is 1, and so on. Okay, that's representation number 2. Representation number 3 is this. If fx and fy belong to the Fréchet domain, then the possible forms for G can be summarized in this form, where A is a function from the unit interval to the unit interval that satisfies these 4 conditions, right? The last condition is that A must be a convex function. Now, I'm sure you guys are experts in math, so a function is convex if and only if the second derivative is positive for all x, right? Okay, so that's representation number 3. Now, representation number 4 is this one. That is, if the marginals of G happen to be exponentially distributed. Remember, this and this are the CDF. I'm sure you know the exponential distribution. This and this are the CDF of an exponential distribution. In this case, the possible forms for G bar, remember G bar denotes the survival function corresponding to G, can be represented in this form, where once again, A is the same function as in the previous slide with the same properties, right? Okay, so that's number 4. And number 5, this is an open problem if you're interested in this area. If fx and fy belong to the viable domain, then there are currently no representations for G. But this is something you may want to work on if you're interested in this area, right? And then I did an example on the representations. This is the example I did. Once again, if you haven't watched the video, I encourage you to watch this video, right? Okay, all right. Now in the remaining time, I'm gonna do an example on the on finding the G, right? On finding what G is. All right, so I will do at least one example. So this is example one. Okay. All right. So you have F bar. Remember, F bar is the joint survival function, right? Now the question is to find G if it exists, right? G, remember, G is the bivariate extreme value distribution, right? So the first step, remember, we need to follow the four-step procedure. The first step is to find the marginals corresponding to F bar, right? You may remember, do you guys remember how to, there is a formula that relates F to F bar, which I gave you some time ago. Do you guys remember that or not? Anyway, if you don't, I will write it down. I mean, you should look back in the videos or the notes. This is a formula I gave you some time ago. You need to remember these formulas. Do you guys remember this? Yeah, this is a formula I gave you some time ago, right? That relates F, the joint CDF, to the joint survival function. So now if you use this, you will get 1, x comma 0 will give you right? This is what you get, right? All right, so this implies that the marginal CDF of x, right, to find the marginal CDF of x, all you have to do is put y equal to infinity into this. You put the joint CDF x comma infinity, that will give you the marginal CDF of x. So if you put y equal to infinity into this expression, this is what you will get. Right? Now to find the marginal CDF of y, you put x equal to infinity into this expression. So that will give you 1. Okay. All right, so this, we are done with step. So this completes the first step of the 4-step procedure. The second step, as you may recall, is to find because these two are univariate distributions. This, what you have here is only involves x. What you have here involves only y. So they must belong to one of 3 possible domains: the Gumbel, the Freccia, or the Weibel, right? So I'm gonna, in step 2, I'm gonna figure out which of the 3 domains it belongs to. I'm sure you've done enough examples, right? So let's take this guy first, right? It is clear that because I should have said at the beginning that that x is greater than 0 and y is greater than 0, right? So So the largest possible value for x is infinity. So the W of fx is infinity. Now, because I know, I've done many examples of this kind. I know for a fact that the condition 1 will not be satisfied, right? So I will go straight into condition. How do we directly assume that the lower bound is 0? Oh yeah, yeah, that's because of this. Yeah, I got your question, Jatin. That's because I should have mentioned this earlier, that the lower bound, because x is greater than 0, the lower bound is 0, and the upper bound is infinity. Yeah, and the same thing with y. Okay, all right. Now getting back to this, the W of fx is infinity. And I know for a fact that condition 1 will not be satisfied. So I will check directly condition 2. You can do that in the exam too. You should think only condition 2 will be satisfied. You can go straight to condition 2, right? Condition 2, I'm sure you guys know, is this. This is condition 2. I'm sure you remember this, right? So this will be the limit 1 minus yeah. Okay. All right. So the 1 here and the 1 here cancel out. All right. Okay. So what you have, because these have the same power, you can write this as limit as t goes to infinity of 1 plus atx divided by 1 plus at to the power minus q. Okay, you guys follow me so far? Right, now the next thing is, I'm sure some of you already know what the answer is, but because you have a t here and a t here, I'm going to divide the top and the bottom with respect to t. So you get in the top, you get 1 over t plus ax, and in the bottom you get 1 over t plus a, right, to the power minus q, right? Now this guy, as t goes to infinity, this goes to 0, this goes to 0, right? So what you have, the answer will be, the limit will be x to the power minus q, right? So we have shown that the condition 2 is satisfied. So the conclusion is that fx belongs to the Fréchet domain. Okay, right. Do you got any questions on this, guys? Patrick, yeah, you've got a question. What intuition of knowing condition would not hold? I mean, it's just, there's no intuition. It's just like you got to do many examples. I mean, it's nothing like an intuition, Patrick. It's just you have to do many examples to get a feeling about which of the three conditions will be satisfied. I hope you understand what I mean. All right. Okay. All right. So that's so F similarly. So I'm going to write similarly. Is the camera working okay or not? It's playing around again. Sorry, I'm checking. Okay, similarly, Fy will also, I'm not going to do it again, will also belong to the Frechet domain, right? Okay. So we are done with step 2. Now step 4. So I'm going to put a cross here. Step 3. I mean, we are done with step 2. So step 3 is to determine AN, BN, CN, DN. Now, if you follow the formulas I just mentioned in the 4-step procedure, I will write them down again if you like. For Frechet domain of attraction, the formula for AN is this, and the formula for BN is this. The formula for CN is this, and the formula for DN is 0, right? All right, to find the formula for AN, you need to find the inverse of the CDF of X at this. So what I'm going to do is I'm going to set the CDF of X, which we know is equal to this, and I'm going to set this equal to this, right? So if I solve this for X, I will get the value for AN, right? So this implies that yeah, all right, and this implies that 1 plus AX is n to the power 1 over q, right? So this implies that X is n power 1 over q minus 1 divided by A. All right, so this implies that AN is equal to all right. Okay, and similarly, I'm not going to do this. Similarly, you can determine what Cn is by taking the inverse of the CDF of Y at 1 minus 1 over n. So similarly, you can determine that Cn is equal to right. So this is our AN, our BN is 0, this is our CN, and our DN is 0. So we are done with step number 3. We are done with step number 3. Now the final step is to find the limit, right? So let me take this away. So this is step number 4, is to find the limit as n goes to infinity of right? This is where your calculus comes in. I mean, I'm sure you guys know better than I do, but all right. So now we know from the question, we know from what we did earlier that the formula, this is the formula I gave, you may recall, this is the f, capital Fx comma y is given by this expression here, right? So what I'm gonna do is I'm gonna put that here. So it's gonna be 1 minus 1 plus an an oh, okay, let me an times ax to the power minus q. Before I forgot to put in the step here. This is the same as the limit as n goes to infinity of, excuse me for clumsy writing. Right, because bn is 0 and dn is 0, we can ignore them, right? So you're concerned only about an and cn, right? Because these two are 0, right? Okay, so now using the formula for f, this is, you can write this as this. Now this looks like complicated, but don't worry, things will simplify in a few steps. Now, at the next step, I'm going to replace an by the formula that we got in the last step, right? Okay, so this is going to be, so I'm going to replace an by the following, which is it. Yeah, and similarly, I'm going to replace Cn by the formula that we got earlier, which is right, and if you don't follow anything, please let me know. I mean these are not difficult mathematics really. Okay, now you see that A and the A cancel out, B and the B cancel out, right? Okay, so you can write this as I'm going to write this in a slightly different form. So like I'm going to write it like this. So I'm going to write 1 minus x plus like this, right? That's the first term. The second is okay, and the third term, there's a plus. Wait a minute. This one here, you have all right. This is what you will get. I know it looks clumsy now, but things will simplify in a while. So this, the above here simplifies to this one, right? Okay. All right. The next thing I'm going to do is I'm going to pull out this term and this term outside the brackets. So I will pull them out here like this, and also I will pull out this term here outside the bracket, right? Okay, right. So if you do that, this you will get. It's difficult for me to show you all the mathematics because I mean obviously I don't have the time for that. So after you pull out this guy outside the bracket and this guy outside the bracket and this guy outside the bracket, this is what you will get. I mean, you can check this in your own time, I mean, obviously. So you will get 1 minus 1 over n times x plus 1 minus x to the power minus q, and then minus 1 over n times y plus 1 minus y minus q, right? And then you will have the following. You have 1 over n squared, because when you pull this out, remember there is a square outside, so it will become 1 over n squared times right. This is what you get, right? Okay, now things started to simplify because Right, as n goes to infinity, guys, this guy here, because you have a negative power, n to the power minus 1 over q, q is a positive number. This guy goes to 0, right? And so is this one. This also goes to 0, right? Okay, so, and over here, this guy here, this guy goes to 0, this guy goes to 0, this guy goes to 0, this one goes to 0, this one goes to 0, and this one goes to, a lot of things goes to 0. You see that, right? So the only thing that remains, is the following. Yeah, that's the first, out of this is the only thing that remains. Out of this, this is the only thing remains out of this. And out of this mess, right, the only thing that you have remaining is okay. You see that? You see, you because many of these terms go to 0. This I mean, horrendous looking expression simplifies to this, right? All right. Now, in the next step, I'm going to use a result that should be familiar to you. So this should be minus, guys, minus, right? Okay, close bracket to the power n, right? You see what I'm trying to do? Okay, now let me call this guy here, the thing inside this. Okay, let me call this guy Z, right? Right. So what you have, guys, is the limit as n goes to infinity of 1 minus 1 over n times z to the power n. Now I'm sure you know this. I think I mentioned this result before in the course. If you have something like this, the limit is e of minus z. I'm sure you probably remember this result. I mentioned this a while ago, right? That the limit of this is this, right? Now I'm gonna put the z back into this. Remember, this is the z, so I'm gonna put it back. Right? Right, I'm gonna put the z back into this, right? So finally, it's just one more step, guys, so don't worry. You're nearly done, right? All right, finally, you should take the limit of this as n goes to infinity. This this guy here goes to 0. So the limit of this is the following: e minus a. All right, this is the limit, and this is your g of x comma y. All right, so I know it looks like a long calculations, but I haven't used anything that you haven't learned in the 3 years you've been here or longer. This is not really difficult calculus or analysis. So is you guys have questions on this? Or, you just need to practice. You need to practice questions like this. You will get a question like this in the exam. So you just need to practice a lot. That's what I mean. Practice many questions like this, you'll be okay, right? Hello guys, talk to me. Are you okay? Are you okay with this example? Or is it too difficult? Okay, so basically you need to follow the 4 steps. So let me take you through. Let me take you through to the 4 steps, what they were, right? So the first step is to find the marginal CDF of x and y. So this is the joint CDF of x and y, and from that you can find the marginal CDF as this and this. And the second step is to, because these are univariate distributions, they must belong to one of 3 limits: Gumbel, Froschio, Weibull, right? And so second step is to determine the domains for these 2 distributions. So here I have figured out that fx, the marginal CDF of x, belongs to the Froschio domain, right? So, and similarly, you can show that fi also belongs to the Froschio domain. You should say belongs, right? Okay, so that's the second step. The third step is to determine the 4 constants, an, bn, cn, and dn. So since fx and fi belong to the Froschio domain, these are the formulas for an, bn, cn, dn. So to find an, you need to set the marginal CDF equal to 1 minus 1 over n, and solve that for x. This is the formula for an, and similarly you can derive cn as this, right? So this is step number 3. Now step number 4 is the difficult part. Step number 4 is to find the limit of this as n goes to infinity. So you need to actually put in the values you got for an, bn, cn, and dn, and you should do that. You will get to this step because bn and dn are 0, and then this is equal to this, right? Because of the given formula for f, right? You get this, and then you put in the value for an and cn, you will get this, right? And then you need to do, well, in this case at least, you need to pull out the powers here, the power of n here, and the power of n outside the brackets, right? And if you do that, you will get to the next step, which is this one, right? And at this step, you will see a lot of things go to 0. This goes to 0. This goes to 0. This. Many of these terms go to 0. So things simplify a lot to this, right? And in the next step, I've written this as this and used this well-known result that the limit of this as n goes to infinity is, I'm sure you know this result, is e of minus z, right? Right, and then you put the z back into this formula, right? And take the limit of n again, so this last term disappears, right? So the final answer that you have is this, and this is the limiting bivariate extreme value distribution, right? All right. I will try to do more examples like this next week when we get to the revision classes. But on Thursday this week, we will go through the tutorial sheet, which is I'm sure you guys know what is the tutorial. Let me show you one more time. So the tutorial for this week is this one here. This is the tutorial sheet for this one, and this is there are 3 questions on this tutorial sheet, I think. Yeah, and these 3 questions are on the representations, which I briefly talked about today. And I will show you how to do this when I meet you guys on Thursday. All right, guys, so do you have any questions you want to ask me right now? Please feel free. Well, I got a question from somebody. You cannot ignore that term, because I think you have to wait till the very last step. I mean, you have to wait till the very last step, which is, I mean, let me show you the camera again. You cannot really ignore that term. I mean, you cannot ignore you have to wait till the very last step, and then argue that this goes to 0 as n goes to infinity, and therefore the limit is this one. I mean, you can't ignore the term at the very beginning. It will not be right to do that. Okay. I know what you're saying, but I think it will be it would be better if you should wait till the very last step and ignore it. Right. All right, guys. Any more questions? Just feel free to contact me 24/7, and hope you guys have a good evening today. I will see you guys on Thursday. But if you have any questions before that, you know what to do. All right. Thank you, guys. Have a good day.